Hey, how's it going? Today we're going to be reacting to another Medium article, and this one is titled Apple Just Pulled the Plug on the AI Hype. Here's what their shocking study has found. I believe this is related to some new study that Apple released a few weeks ago around them debunking AI's reasoning. They're basically saying that AI doesn't actually reason, but it's just really good at pattern matching. I didn't actually read that article. To me, my initial reaction to that entire ordeal was that they're trying to save face in some way. I feel like because Apple, they've come out and admitted that they're just really behind on their AI initiatives, and I think there's a lot of reasons why it's behind, especially due to their high bar for privacy. But anyways, let's dig into this article and kind of get more informed on this topic. This article is by Rohit Kumar Thakur. Sorry if I butchered your name, but here it goes. New research reveals that today's reasoning models aren't thinking at all. They're just sophisticated pattern matchers that completely break down when things get tough. It's a nice picture of Apple and Unsplash, as usual. We're living in an era of incredible AI hype. Every week, a new model is announced that promises to reason, think, and plan better than the last. We hear about OpenAI's o1, o3, o4, Anthropic's thinking Claude models, and Google Gemini's frontier systems, all pushing us closer to the holy grail of artificial general intelligence, AGI. The narrative is clear. AI is learning to think. But what if it's all just an illusion? My take here is, does it matter whether AI is actually reasoning or not? As it currently is, in my opinion, I don't think it matters that much. I don't think that's what's contributing to the hype. Every now and then we get these articles or some random videos about how AI is trying to prevent himself from unplugging itself and just these random funny stories. But to me, I think why there's so much hype around AI right now is because these systems are providing real solutions and new ways of solving problems that just never was possible before. And it's making dramatic changes in a lot of different industries. Coding, lawyers, accounting, all industries is going to be affected by AI. Whether or not we find out later down the line that with the current transformer architecture, maybe reasoning is not really possible and it's just pattern matching, I would argue that why does it matter at all if it can still, with the pattern matching, solve all these problems? But anyways, what if these multi-billion-dollar models promoted as a next step in cognitive evolution are just running a more advanced version of autocomplete? That's the bombshell conclusion from a quiet, systematic study published by a team of researchers at Apple. They didn't rely on hype or flashy demos. Instead, they put these so-called large reasoning models, LLMs, to the test in a controlled environment, and what they found shatters the entire narrative. In this article, I'm going to break down their findings for you without the dense academic jargon, because what they discovered isn't just an incremental finding, it's a fundamental reality check for the entire AI industry. There's a little extra comma there. I just highlighted it. I don't know what a highlighting actually does. One thing I want to add here is it makes me wonder why they're putting so much effort into debunking this. What's the point? They could have spent all of this research on just making their local LLMs better and their whole private cloud architecture better. Instead, they're just having a bunch of researchers. Honestly, I feel like it's a waste of time given where they are in the current race for the AI stuff. But, I don't lead Apple. So if I were tinfoil hat, it's more they're trying to lower the hype of AI so that they don't look as bad because right now they're really behind. Maybe that's their 4D chess move. Why we're being fooled by AI reasoning? First, you have to ask, how do we even test if an AI can reason? Usually, companies point to a benchmark like complex math problems, Math 500, or coding challenges. And sure, models like Claude 3.7 and DeepSeek R1 are getting better at these. But the Apple researchers point out a massive flaw in this approach: data contamination. In simple terms, these models have to be trained on a huge chunk of internet. It's highly likely they've already seen the answers to the famous problems, or at least very similar versions, during their training. Think of it like this. If you're given a student a math test, but they've already memorized answer key, are they a genius or just good at memorizing it? Okay. This is why the researchers threw out the standard benchmark. Instead, they built a more rigorous proving ground. So I guess like the high level idea is saying the tests are rigged. AI knows the test, so they're just matching the patterns. So why don't we create like a brand new test that AI has never seen? Seems reasonable, but let's see. The AI proving ground puzzles, not problems. To truly test reasoning, you need a task that is 1, controllable. You can make it slightly harder or easier. 2, uncontaminated. The model has almost certainly never seen the exact solution. Number 3, logical. It follows clear, unbreakable rules. Honestly, number 2 seems very difficult to do, mainly because I feel like nothing is original under the sun anymore. Like everyone has like thought about something or wrote about something. You know, a lot of things are variants of things, but there's like a core similarity. I just don't know like how truly uncontaminated some new tests can be, but who knows? So the researchers turned to the classic logic problem: Tower of Hanoi, blocks, rivers, river crossing, and checker jumping. So this already to me, I don't know why it lines up with number 2. It feels like it's already kind of breaking that like uncontaminated theory or rule. These puzzles are perfect. You can't fudge the answer. Either you follow the rules and solve it or you don't. By simply increasing the number of disks in the Tower of Hanoi or blocks in Block's world, they could precisely crank up the complexity and watch how the AI responds. Okay, so here's some graph. This is where the illusion of thinking began to crumble. The shocking discovery: AI hits a brick wall. When they ran the tests, a clear, disturbing pattern emerged. The performance of these advanced reasoning models didn't just decline as the problems got harder, it fell off a cliff. The researchers identified 3 distinct regimens of performance. Low complexity tasks. Here's the first surprise. On simple puzzles, standard models like the regular Claude 3.7 Sonnet actually outperformed their thinking counterparts. They were faster, more accurate, and used far fewer computational resources. The extra thinking was just inefficient overhead. Okay, medium complex size. This is the sweet spot where the reasoning models finally showed an advantage. The extra thinking time and chain of thought processing helped them solve problems that the standard models couldn't. This is called a zone that AI companies love to demo. It looks like real progress. High complexity tasks. And this is where it all goes wrong. Beyond a certain complexity threshold, both model types experience a complete and total collapse. Their accuracy plummets to 0, not 10%, not 5%, 0. Okay, so for the first point about low complex tasks, non-reasoning models doing better, I mean, this makes sense. This is kind of how I use AI models right now. Like I kind of really think about what model is good for this particular query. If it's a query that I think is kind of more involved, I'll look for reasoning models. If not, I'll look for the speed. So it makes sense. And in that vein, medium complex tasks, it makes sense to use the O3 model or like the reasoning model. This whole like high complexity tasks falling to 0, I don't really know how they tested this. I mean, I'm sure I'm going to find out, but I feel like it's probably a context window issue more than anything. It seems like, at least from the way they were describing the problems above, complexity to them point to just like context issues, like context size issue, but we'll see. This isn't a graceful degradation. It's a fundamental failure. The models that could solve a 7-disc Tower of Hanoi puzzle were utterly incapable of solving a 10-disc one. See, like, this is what I mean. It's just growing the number. So, like, I feel like it might be a context window issue. Even though the underlying logic is identical, this finding alone destroys the narrative that these models have developed generalizable reasoning skills. Even weirder, when the going gets tough, AI gives up. This is where the study gets truly bizarre. You would assume that when a problem gets harder, a thinking model would, well, think harder. It would use more of its allocated processing power and token budget to work through the more complex steps. But Apple researchers found the exact opposite. As the puzzles approached the complexity level where the models would fail, they started to use fewer tokens for their thinking process. This is a very weird behavior, honestly. Like, I'm not really sure what's going on or like why. I'm sure a lot of AI researchers might have more clues as to why this happens. If you know the answer, comment below. Let that sink in. Faced with a harder challenge, the AI's reasoning effort decreased. It's like a marathon runner who, upon seeing a steep hill at mile 20, decides to start walking slower instead of digging deeper, even though they have plenty of energy left. It's a counterintuitive and deeply illogical behavior that suggests the model knows it's out of its depth and simply gives up. This reveals a fundamental scaling limitation. These models aren't just failing because the problems are too hard. The internal mechanisms actively disengages when faced with the true complexity. So I don't know if this is related, but one thing that this entire statement reminds me of is actually AlphaGo and the God move that Isidore, the Korean player, did during the whole AlphaGo movie documentary. So for those of you guys who don't know that story, basically Isidore was at the time the best player in the world for the traditional game called Go. He no longer is actively playing, he retired. But the point is he had a match with AlphaGo. It's an AI bot from Google's DeepMind, and they made headwinds a long time ago, even before all of the AI hype. AlphaGo was the first AI moment that I remember. I'm sure there was some before then, but that was the most viral AI moment. But basically, they played 5 matches, I think, and then in the 4th game, Isidore made this one move that kind of confused the AI. That's what they were saying. And then after that, it kind of played really horribly, and then it just lost the match from that point, like AlphaGo did. It made me think of that same game because it's kind of like this, where the AI was given such a hard problem that it kind of gave up and looked for a way to mitigate their loss or something. But yeah, that's just a very interesting parallel. Inside the AI's mind, a tale of overthinking and underthinking. The researchers didn't stop at just measuring final accuracy. They went deeper, analyzing the thought process of the model step by step to see how they were failing. What they found was a story of profound inefficiencies. On easy problems, models overthink. They would often find the correct solutions very early in their thought process, but instead of stopping and giving the answer, they would continue to explore dozens of incorrect paths, massive amounts of computations. It's like finding your keys and then spending another 20 minutes searching the rest of the house just in case. So I think this is an oversimplification of the problem statement, because let's say that you're solving some math problem or something like that, you might spend, after you found the answer, you might actually spend time to verify that you got it correct or try something else. Sure, if it's a really easy problem, have I found my key or not? Did I get the answer right or wrong? Then, you might just do it. But if you're just solving something that may or may not be right, and you don't know if it's right, then you might spend some extra time to try to verify that you're right. I don't know if this makes sense 100%. On hard problems, models underthink. This is the flip side of the collapse. When the complexity was high, the models failed to find any correct intermediate solutions. Their thought process was just a jumble of failed attempts from the very beginning. They never even gotten on the right track. I do think sometimes AI gets into this weird state. Even in my cursor usage, I found that sometimes you could see it kind of going over and over doing the same thing and being stuck. And you need to change up the context or change up the questioning or change up the prompts in some way to get it unstuck and then move forward. Maybe it's just a current limitation of the current architectures in the system. Both overthinking on easy tasks and underthinking on hard ones reveal a core weakness. The model lacks robust self-correction and an efficient search strategy. They are either spinning their wheels or getting completely lost. The final nail in the coffin, the cheat sheet test. If there were any lingering doubt about whether these models are truly reasoning, the researchers designed one final damning experiment. They took the Tower of Hanoi puzzle, a task with a well-known recursive algorithm, and literally gave the AI the answer key. They provided the model with the perfect step-by-step pseudocode algorithm for solving the puzzle. The model's only job was to execute the instructions. It didn't have to invent a strategy, it just had to follow the recipe. The result? The model still failed at the exact same complexity level. This is the most crucial finding in the entire paper. It provides that the limitation isn't the problem solving or high level planning. The limitation is the model's inability to consistently follow a chain of logical steps. If an AI can't even follow explicit instructions for a simple rule-based task, then it is not reasoning in any meaningful human sense. It's just matching patterns, and when the pattern gets too long or complex, the whole system breaks. Okay, so two things that come to mind. Number one, I guess I'll still have a job for at least a while until they figure this problem out, because if they can't follow like simple instructions just because the complexity length has grown, then I'm still in good shape. I feel like coding jobs or, software jobs, like coding is maybe 30%, right? The rest of it is dealing with all these like complex, very intricate like business decisions and communications. And there's just a lot that goes into an engineering job, right? So I feel like, at least for me, I'm still safe for a time being. The other thing that I'm thinking is, yes, I do think that like context window thing that I was talking about, it does feel like it is really like a context window. So what are we actually witnessing? The Apple study titled The Illusion of Thinking forces us to confront an uncomfortable truth. The reasoning we're seeing in today's most advanced AI models is not a budding form of general intelligence. It is an incredibly sophisticated form of pattern matching, so advanced that it can mimic the output of human reasoning for a narrow band of problems. But when tested in a controlled way, its fragility is exposed. It lacks the robust, generalizable, and symbolic logic that underpins true intelligence. One thing that I don't understand about this particular article is this whole statement that this is some uncomfortable truth. Like I said, I don't think it matters at all. I don't think it will discourage people at all. It actually makes people like me, who is engineers or these knowledge workers, a little bit less afraid of AI at its current state. My take on this is twofolds. One is I think eventually they'll figure this out. All of the core AI model company, AI labs, they'll figure this out. They have been figuring out all these other things. Things, in my opinion, is still very early in the AI whole ecosystem. We're still early in the hype train, even though it's been a few years. I just don't think we'll slow down as much as people are thinking. The other take is that I think Apple just has incentive to make AI less of a thing. So here's the thing about Apple, in my opinion. Right now, they're really in this tough position because they're really harping on this ODML, on-device machine learning, LLMs, because they've been such a big advocate for privacy. Their entire brand, if you think about Apple, sure, iPhones and MacBooks and all this thing is a big deal, but the other kind of big brand that they have is around privacy, and it's such a core component to their branding. It's hamstringing their AI advances, in my opinion, because they can't just simply say, oh, we're not gonna care about privacy anymore and let's just run all of our LLMs on servers. Right. So they're putting so much effort into this ODML LLM approach, in my opinion, that they need a way to slow down this other things so they have time to catch up. This past WWDC, they barely mentioned anything about AI. And I think some of the VPs already came out straight up said to the media that they're delayed because the quality bar is just not there. How can you beat LLMs that are running on multiple H100s on a small, tiny, just Apple Silicon, right? Apple Silicon is amazing. You just can't compare your on-device models to something that can be run on massive H100. It's just unfair, right? And because the quality bar is being currently trained by the public on ChatGPT's server-based H100 based models, you just can't compete. It'll just feel like crap when you have some local on-device model spitting out output. It'll just feel like crap, I think. All right, where was I? It's an incredibly sophisticated form of pattern matching, so advanced that it can mimic the output of human reasoning okay, I already read this part, sorry. The bottom line from Apple's research is stark. We're not witnessing the birth of AI reasoning. We're seeing the limits of a very expensive autocomplete that breaks when it matters most. I actually really disagree with this because I think most of the use cases, it has not broken, at least for me. What we need it for most most is that like not complex and like medium level complexity tasks. Like the really complex part, like I don't think we need it that often yet. The AGI timeline didn't just get a reality check, it might have been reset entirely. So the next time you hear about a new AI that can reason, ask yourself, can it solve a simple puzzle it's never seen before? Or is it just running the most expensive and convincing magic trick in history? Like I said, I don't really like know why the author is like kind of making this like a doom and gloom thing. I think it's just like an interesting take that Apple has put out, research. Like to me, AGI is a thing that will eventually probably happen. And this doesn't really change anything for me personally. I'm still going to use like Gemini and ChatGPT and all these like AI tools because it's still very helpful. I don't care that it's like a really, really good autocomplete because the magic trick, as the author is putting it, is really good enough to do amazing things in my personal work streams in my life. But yeah, this was a really good article. If you guys are interested in like these kind of React contents, I have an entire playlist where I just react to like Medium articles and other articles. Feel free to send over any articles that you want me to read. And with that, I hope you guys enjoyed this quick video. And until I see you guys on the next one.